So our next topic is interference. So what is interference? So interference is a non-conjugate mating of the two engaging surfaces. Then it will gives the interference. So we have already seen what is a conjugate. The conjugate one is the which that the surfaces are the profiles which satisfy the law of Gehring. But if these are not satisfying the law of Gehring, then those are called as a non-conjugate mating. So what happens if these are not conjugate? For example, in the involute, what happening? So in the involute, we have a gear and this tooth like this. So the other tooth is touching like this to the other one. So when these two are here, these two tooths are touching tangentially. So under these two are conjugate. That means these two are involute profiles. This one is involute and this one also involute profile. So when these two are involute profile, what happening? The force is transmitting in the normal line drawn at this point. So if you draw a normal line at this point, this is something like this. So this is a tangential to the base circles and this is normal to this one, and the forces are transmitting along this line. But if the one profile is a involute and the other one is not involute, this is not involute. For example, this is a not involute. Then these two becomes non-conjugate. And if these two are non-conjugate, then there is no rule that that common normal will exist at this one, and the forces no longer transmit along the common normal here. Generally where it occurs, because we have drawn involute profile tooth, and the when these both tooth are involute, then there won't be any chance of it becoming a non-conjugate contact. So generally where will it occur? So it occurs not on the surface of the tooth. It's not on the surface of the tooth, but instead, if this tip is coming further, if this circle is like this, and if this teeth is coming further, and if it is touching this one, and here we provided some gap like this clearance, and this clearance is may not be an involute. So if this is coming and touching this one, then in that case it will become non-conjugate. That means it's not on the surface, but it's at the bottom of the base circle generally. So the contact or non-conjugate action is not at the surface, but instead it's happening or occurring at the bottom of the base circle. Stop. Start. So what is the implication of this interference? So we have already seen that in case of interference, the transmission of motion is disrupted, and it's not along the common normal at the contact point. So this is a common normal at the contact point, and this force is not transmitting along this one. Our motion is not transmitting along this one. So our motion is disrupted in this case. So that's what happening in this because of the interference. So we know that interference is undesirable. So then how to avoid the interference? The first, there are so many methods. The first one is a center distance, increasing the center distance. But this is this is a limited one, because we cannot increase the center distance in case of a cycloidal one. What happens in case of cycloidal one? If you increase the center distance, then it no longer satisfies the the condition where the requirement of maintaining the constant angular velocity ratio. So it's no longer constant if you increase the or if you change the center distance. But whereas in case of involute gear, we can alter the center distance without affecting the constant angular velocity ratio in case of involute. So we will see how the center distance, by increasing center distance, how can we avoid the interference. So these are the two gears which are in the engagement. So originally this is the center distance, and this tip is nearly coming closer to the base circle of the gear A. But if I increase the center distance, what happens? The same B will become like this. Now the red color one is the new position of the gear B. So we increased B to the B dash, so that center distance is increased. But still these two gears are in the contact, because this still this tooth on the gear B is in contact with the tooth on the gear A. So still there is a motion between these two. But here the distance is increased between the end of tip of the tooth to the base circles from the two gears. So what happens here? The chance of interference greatly reduced in this case. So if the interference is mainly occurring at the bottom of the base circle, then in this case by increasing the center distance we can avoid the interference. And the second one is by increasing the pressure angle. So by increasing the pressure angle, so this is the original pressure angle when two gates are in the action. So now we need to now increase the pressure angle. So for example, I increase pressure angle to here, and in this case to here, or something like this. So so that means the common tangent should pass through these points now. So these points like this. But if these center distance between these two gates are A and B, if the without changing center distance, we cannot draw common tangent, because at any position, at any given position for the two gears, we can draw only one tangent. Of course, one tangent from in the opposite direction also we can draw. But if you consider only in the one direction, then in that case we can draw only one tangent, that is touching these two base circles. But to draw another tangent, that is touching this new position, then without changing the center distance AB, we cannot draw this one. But how to draw this one? For example, if I bring this AB bit closer, then in that case what happens? This will happen. So in that case, if I draw something like this, this is the new tangent. Then in that case what happens? This would be the new tangent. This is the B gear. This is the B gear, and this would be the new tangent. Or I will draw with a green color. This would be the new tangent. What happened? This is the new tangent, and in this case, this phi value further decreased. If I bring these two gears further, closer, then what happening? This phi, instead of increasing, this is a decreasing here. So to increase the phi value, instead of bringing this gear closer to A, then we need to take this gear bit farther to the A. So in that case only this phi value will decrease. Why? Because in that case, if I draw new tangent like this, then only it will come like this, and here this is touching here. So in that case what happening? This phi value is automatically increasing. So what I am trying to give some insight here is, whenever you want to increase the phi value, then without changing any geometrical alternations, or without changing any geometry of the gear, only the possible choice is increasing the center distance between these two gears. So automatically when you increase, we have seen in the above case that with increasing the center distance, automatically interference would be avoided. Another way of avoiding the interference is limiting the addendum value, because the tip of the tooth is touching the base circle. So that's why we need to limit the addendum value. And generally out of these above three, first two, that means center distance and as well as the pressure angle is always fixed. Whenever there is an engagement, or whenever we are engaging two gears, then those first two are generally fixed. The only thing we can alter is the last one. So addendum radius, that means the addendum radius, RA or a capital RA will decide the whether interference occur or not. We'll see how minimum number of gears on the pinion and gear will decide the interference. So here how the number of teeth on the gears decide the interference. Number of teeth on the gears affect the interference. For example, these two gears are in the engagement, and if there are not too many gears, so gears are distributed like this. One gear is here, one gear is away from this one, and here also it's distributed very away from one another like this. So what happens when these two are in contact? So and this center distance is very closer, then what happens, this will touch here when it is rotating like this, and after that there won't be any motion until it touches again this tooth on this one. Then meanwhile, because of this because of this gap between these two, it may come and touch the base circle. But instead, if this is a having these many gates, so instead of this is going down, it immediately touches this and it may not go up to the bottom. That means the number of gears that are having, the number of teeth on a gear also affecting the interference. Then we will see what are the minimum number of teeth that are required on a gear to avoid the interference.